right. So we're here for Work Energy 3, doing problem 7. Okay. A simple 2-meter long pendulum is released from rest when the support spring is at a 25-degree angle with the vertical. So we're letting go of it with it pulled back a little bit, right? We're going to let go. It's going to swing down, right, and back and forth. What's the speed of the pendulum bob at the bottom of its swing? All right. So we're going to do a little energy calculation here. Let me get a sheet of blank paper, and we'll draw our sketch. All right. All right. So here we go. All right. So slide that down a little bit. There we go. I think that's good. All right. So drawing my sketch. Problem 7. Okay, I'm going to make my picture nice and big, okay, because we're going to do some fancy geometry on it. Okay, not that fancy, but we're going to do some geometry on our sketch. There's my pendulum bob. Now, this is a vertical line, okay. I know this thing is going to swing along in an arc here. Okay, I'm kind of exaggerating a little bit, I know. Sorry. It's going to swing along from there to there, right? All right. Okay, now we know that this is 2 meters long, all right, which means this length here is 2 meters long, right? And we know that it starts off at a 25-degree angle. We want to know the speed when it gets down to here, okay? So at the end, we want to know, we're going to start it from rest here. V naught is 0. And we're trying to find the V here at the end. All right. So we're going to do our energy calculation, from here to here, right? No surprise. Okay. Now I know that one of the next step of solving my energy problem is to do a force diagram. So here's that pendulum bob in the middle of that motion, okay, at some generic spot in the middle of the motion. All right. Not doing the special cases. You say, well, I would have 2 forces in that pendulum bob, wouldn't I? There'd be a gravitational force, and there'd be that tension. Okay. And there's some angle this is making with the vertical. I know it starts at 25, but in the middle it'd be at some weird angle or whatever while it swings along, and that's okay. All right. But that's it. Those are the forces. You might say to yourself, that's okay. All right. So, ready to go to the work energy theorem. So you'd say, our work energy theorem, we do sigma W is delta K. Work kinetic energy theorem. And I say I write a work term for every force. So I have like work done by tension and work done by the gravitational force is my final kinetic minus my starting kinetic, expanding out that delta, right? You say, now some of these terms will be 0. You say, well, I know the work done by the tension is 0 because while we're swinging, tension is always acting perpendicular to the velocity. The velocity is always tangent to the path, and that's a radial force inward. It's not going to do any work. So because the tension is perpendicular to the motion, okay, so it does no work. I'm going to go ahead, and I also know that this thing is starting from rest, so K naught is 0 because V naught is 0, right? That's why that drops, okay, because V naught is 0. Now, so right now I have gravity does work on this thing, tugging on it, making it speed up, gaining kinetic. That's what's happening. Gravitational force doing work, giving us kinetic energy. But I could choose to expand my system. And so my system won't be just the pendulum bob. It'll be the bob and the earth. So now I'll have a delta UG, because that's not an outside force anymore. That force from the earth pulling on the bob, that's a force between parts of my system. But I'm rearranging that system, and so I'm changing its potential energy, its energy, because of its configuration. So I'll have a UG final minus UG initial. Okay. Now, when I do UGs, I have to decide where I want to call height 0. It would make, most people like to make the lowest height in their problem 0. So then their heights are all positive values. I'm going to go ahead and do that this time. Okay, so I'm going to choose to call the height here at the end. I'm going to choose to call, I'm going to call the height here 0. Okay, well, that's sloppy. That's supposed to be horizontal. Sorry about that. Anyway, the height here at the end, it's going to matter for what I'm going to sketch here in a minute. Make that height 0 there. That means my final height is 0, and that means because the final height is 0, that final potential energy term is going to be 0. It's going to drop out. So here we go. The work energy theorem showing only the non-zero terms. There are no work terms left. I have a final kinetic, and I have an initial gravitational potential. That is my equation. Look, as it swings down, we're losing gravitational potential, gaining kinetic. Ta-da! Okay, let's put in what we know. 1/2 mv final squared. That's our kinetic energy term. We're trying to find that final velocity. So this is good stuff. Potential energy is mg, and then this is the starting potential, so it's the starting height. That means I have to figure out what my starting height is. All right. This is the trick to this problem, and that is to do a little bit of geometry here. I'm going to check out what I'm going to do. I'm going to construct a horizontal line here. Right? Which makes this a 90-degree angle between the vertical and that horizontal line. Look, it's a triangle, right triangle. The hypotenuse, I know, that's the length of the rope. That's 2 meters. This is 25. This is the adjacent leg. So watch this. This here, how long is that? That's 2 cosine 25 degrees, right? Hypotenuse times the cosine gives me the adjacent, right? Which means, what was my height here? Well, this whole rope is 2 meters long, isn't it? So this chunk is 2 meters minus 2 cosine 25. So this here is 2 minus 2 cosine 25. Ta-da! Okay, and so if this is height 0, the height here is 2 minus 2 cosine 25. That's my starting height. So I will substitute that in there where it says h naught. In fact, let's flip it around to the other side. Make them both terms positive. So I'm going to have 1/2 m v final squared equals mg, and my starting height is 2 minus 2 cosine 25. Okay. All right. Hey, notice there's a mass in both terms. Every term has an m in it, so I can drop the m. You say, hey, that's good news because I didn't know what the mass was of the pendulum bob. Turns out it doesn't matter. Okay, I'm trying to find v final, so I'm just going to move a 2 over there and take a square root. So I'm going to have 2g times 2 minus 2 cosine 25. Take a square root. That'll be my velocity. Let's put the values in. 2 times 9.8 times 2 minus 2 cosine 25. Punch that in my calculator, and I got a value of 1.92 meters per second. Ta-da! And that's that problem. So what I'm showing you here is that trick for finding heights here is going to be to construct a horizontal line over and then recognize that this full length is the length of the rope, is this full length here. But I can use, with this right triangle, I can find this chunk and then just say this is the whole length minus that. Okay, important trick we're going to use in the next problem too. All right, that's it for problem 7.